Section 6.2, Law of Cosines. Students will learn to use the law of cosines to solve oblique triangles, side, 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 and side angle, side. So when you guys are solving these, you're going to have to know whether should I use law of sines or law of cosines. So today we're going to do side, 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 and side angle, side for law of cosines. And if it's either one of these case 3 and 4, you won't be able to use law of sines because you don't have the information to be able to do so. So we have now law of cosines. So this is what we have, side angle, side, an included angle, and here are the formulas for law of cosine. A squared is equal to b squared plus c squared minus 2 times b times c times cosine of A. Now, the reason I have 3 of them there is because it just depends on which side you're solving for. They're all the same in terms of if you look at what it starts with, which is the a square, it ends with cosine of that angle opposite. If it's b squared, it ends with cosine of that angle opposite, which is cosine of b. So they're all the same. It's just based on which side of the triangle that you're actually going to be using for each of these. Now, useful for finding an angle. These are the ones out of the book. Cosine of a is equal to b squared plus c squared minus a squared over 2bc. When we get to the first example, I'm going to show you, I don't use exactly the same one out of the book. They all work the same, but I don't do the last step that they typically do in the book, and I'll kind of show you what I mean by that. But this right here, in terms of what we're looking for, these will be the formulas, and really just one of them is what we'll be using, but depending on the side length is how they change. So let's look at our first example here. So if you take a look, we have A, B, and C, so we'll set up our triangles again. Angle C is 95. These are not drawn to scale. Side A is 3, side B is 2, and then side C we don't know. So this is side, angle, side. So it's an included angle. That's different than angle, side, side, which is law of sines. So looking at this, we have an included angle and 2 side lengths. So we want to solve for side C, which means we'll be using this one, but like I said, it all works the same way. So no matter what the side is, it'll be that side squared is equal to one of the other sides. I'll use in this case the A because that's what it says, but 3 squared plus B squared minus 2 times AB, which are the same values that you used to square. So minus 2 times 3 times 2, and then cosine of angle C, which we know as 95 degrees. So you're going to take all of that and plug it into the calculator. Make sure your calculator is in degrees, and you will get a value approximately for C squared to be 14.0458, and so on. You can see it over to the side. Right here is the number that you calculated. Now, that's C squared, so we want to take the square root of that, and sides are measured to the nearest hundredth, so that'll be approximately 3.74, but the 4 gets rounded up to 5, so 3.75 for that side length of C. So now we have all 3 sides and an angle. So we need to use one of the other formulas to find the angle. So let's say we want to find angle A. All right. So we want to find angle A. So to find angle A, before I write it down, I'm going to go up to this formula right here. That's where A is located. But it's all solved for A squared. So we want to solve it for A. So how do we do that? Well, we can take the A squared, subtract the B squared, subtract the C squared, and then that would leave us with negative 2BC cosine of A. Now then you can divide by negative 2BC, negative 2BC. So cosine of A is equal to A squared minus B squared minus C squared over negative 2BC. And you can always do that on your own. You don't need to memorize that formula. And that was the one I was talking about right here. I feel like you're just going to memorize more formulas, where in reality you can create that formula again just by solving for cosine of A. So now we know that cosine of A is equal to A squared, which we know is 3, so that's 3 squared, minus B squared, which is 2, so minus 2 squared, minus C squared, and we'll have to approximate that one at 3.75 squared, divided by negative 2 times B, which is 2, times c, which we found to be 3.75. So once again, the one I'm using is a little different than what the textbook uses. I didn't get rid of the negative in the denominator because it wasn't going to matter. I was going to plug all this stuff in anyways. So once you plug that into your calculator, look at my screenshot of my calculator here, you have parentheses in the numerator divided by parentheses in the denominator. And so you approximately get 0.604 whatever. Then you use the inverse of cosine so that you can solve for the angle A. So A is approximately 52.8 degrees. And now that you have two angles, you can solve for the third angle by subtracting. So we will find angle B, which is the last one. So that's equal to 180 minus the original 95 degrees minus angle A, which is 52.8 degrees. And if you subtract all those, you will get 32.2 degrees. And so you've solved the triangle. Here's angle B, here's angle A, and then side C. And so that is using the law of cosines to solve a triangle. I have one more example for you. This is a side, side, side. It still works the same way, except now you don't have any angles, so you're going to have to find all three angles. So if we call this A, this would be 10, B, this will be 8, and C, this would be 5. So instead of starting with a side length that we're missing, we have all of them. We're going to have to solve for our three angle measures here. So if I just do cosine of A to start off, cosine of A is equal to A squared, and then you're going to subtract B squared and C squared, and then you would divide by the negative 2BC. And that's the one that you'll use to plug everything in and calculate. So what do we have? Cosine of A is equal to A, which would be 10 squared, minus B squared, that's 8 squared, minus C squared is 5 squared, divided by negative 2 times 8 times 5. Plug that into your calculator. You'll get cosine of A is approximately, I got negative 0.1375, and therefore angle A to the nearest tenth is 97.9 degrees. And you'll do this again with one of your other angles that you're still missing. So I'll do cosine of B. This will now be B squared, and then you'll subtract A squared and C squared, and then divide by negative 2 AC. So we'll plug in the values. B is 8, so 8 squared minus 10 squared minus 5 squared divided by negative 2 times 10 times 5. And so if you plug that in, you will get a value of 0.61. Use the inverse of cosine, and that will give you 52.4 degrees. And then the last one, you can take angle C and do 180 minus A minus B. So that will give you C is equal to 29.7 degrees. So those are your three angles when you're given side, side, side of a triangle. And that's it for law of cosines. So now if you want to write a little summary in terms of these notes as to what's important, go ahead and do so, and then I'll kind of write mine as well. So here's my summary. Once again, I mean, this is for you, it's not for me. Law of sines, I was just thinking that, okay, I got two different types of triangles, side, angle, side, and side, side, side. So I wrote the two formulas basically I would need with when I am solving for a side length, and then on the second one where I'm solving for an angle, so I could include that, I guess, as well. And then the other thing that I thought was important to realize is that with law of cosine, we have side, angle, side. Law of sines, we have angle, side, side. The difference is law of cosines, the angle is included. Law of sines, the angle is not included, and this is also our ambiguous case where we get the different number of triangles as well. So just paying attention to when you can use law of cosines and when you can use law of sines.